Hello, everyone, and welcome to today's Safety and Health webcast, Technology for Next Level Hearing Loss Prevention Programs, sponsored by Honeywell. This is Alan Ferguson, Associate Editor at Safety and Health magazine, and I am moderating today's learning opportunity. Thank you for joining us. But before we start this presentation, I want to go over some preliminary items. As a disclaimer, the views of today's speaker and organizations are their own and do not necessarily reflect those of the National Safety Council or Safety and Health magazine. Any mention of a commercial enterprise, product, or publication does not mean the council or magazine endorses those items. Next, I want to let you know that at the end of today's webcast, we are conducting a question and answer session. To ask a question, simply type it in the text box in the lower left-hand corner of your screen and click the button for Submit Question. Feel free to ask your question at any time during this presentation. You don't have to wait for the Q&A to begin. We'll try to answer as many questions as possible, but we might not have time to get to every question. The good news is that any unanswered questions will be forwarded to today's speaker. At the end of this webcast, you'll be asked to complete a brief evaluation survey, and I'll give you more information about that after this presentation. This webcast is archived, so you can access it after today's live event. To listen to this webcast and all of our past webcasts, go to safetyandhealthmagazine.com/events. And if you'd like more information, please see our resources tab. And finally, if you need troubleshooting information, click the help button located on your screen. With that, let's go ahead and get started. Our speaker today is Robert Gint Jr., Manager and Research Audiologist at the Howard Light Acoustical Testing Laboratory for Honeywell Safety Products. Robert has more than 3 decades of experience in the prevention and remediation of hearing loss. During that time, he served as a clinician, a university instructor, hearing conservationist, and researcher. At the Howard Light Laboratory, Robert supervises the testing of hearing protection and conducts research and best practices for hearing loss prevention, product development, and expanding the knowledge base of his profession. Bob, whenever you're ready, go ahead and take it away.
Thank you, Alan. And thanks, everyone, for joining. I'm Bob Gint with Honeywell Safety Products, and I appreciate this opportunity to speak with you today about some of the ways technology can take your hearing loss prevention program to the next level. Even though we use the term hearing conservation by convention to describe our efforts to protect workers' hearing, the idea of hearing conservation is different from that of hearing loss prevention. Hearing conservation acknowledges hearing loss as an accepted fact of occupational life. It views hearing loss as a decline in a sensory function due to an expected insult from an occupational hazard, as if there's nothing that can be done to keep it from happening. It's only after the hearing loss is identified that we attempt some intervention to ensure it doesn't get worse or happen to someone else. It's a reactive response to the problem. Hearing loss is, in fact, a permanent, uncurable chronic health condition, an illness rather than an injury that will heal like a paper cut. Research in the past several years has linked hearing loss to other serious chronic health conditions such as cardiovascular disease, serious emotional issues, and cognitive decline. Hearing loss acquired on the job is not acceptable. It is 100% preventable. Preventing hearing loss, and not just keeping it from getting worse, requires a proactive approach. We need to change the way we think and talk about it. So while we may refer to hearing conservation programs, the purpose of the program is hearing loss prevention. Throughout this presentation, I will use the terms hearing loss prevention and hearing loss prevention programs, and that will be our mindset as we talk about technology today and what the next level looks like. First, we'll review briefly why and when you need a hearing loss prevention program. We'll also go over the elements that constitute a hearing loss prevention program and some of the challenges you may face implementing them. This will lead us into the heart of our discussion about new technologies that can make implementation easier and execution more efficient. We will see how technology solutions engage individual workers and make hearing loss prevention personal. You need a hearing loss prevention program in your workplace for the same reasons other safety measures are established at work. Employees have an expectation and a right to go home at the end of the day as healthy as they were when they started their workday. With respect to occupational noise exposure, we need to protect workers from the damaging effects of hazardous noise, starting with the prevention of hearing loss. Hearing loss is an invisible injury. You can't see it. There may not be any pain or discomfort associated with it, and it tends to progress slowly over time. It can take some time, often years, before a worker recognizes that they are losing their hearing. Because of this, they may wait even longer to do something about it. Noise-induced hearing loss is permanent and can have devastating effects on one's quality of life, even beyond difficulty hearing. Having a proper hearing loss prevention program in place helps keep hearing loss from getting started. If someone already has a hearing loss, we want to make sure we protect their remaining hearing. You never want to hear, "Oh, I already lost my hearing. I don't need to wear hearing protection." Or, "If I lose my hearing, I'll just get a hearing aid." Hearing aids don't restore lost hearing. They only make use of the hearing that remains. Plus, they are expensive and never sound as good as natural hearing. It is vital to protect hearing on the job. We also want to prevent tinnitus, that ringing in the ears that sometimes follows a noisy event. Tinnitus is often a temporary condition, but can become permanent. Much like hearing loss, the effects can range from annoying to debilitating. Noise exposure has also been associated with other health issues, as I mentioned, called comorbidities, such as elevated stress levels and associated chronic health conditions like cardiovascular disease. We definitely want to avoid that. A hearing loss prevention program will allow you to verify that your hearing loss prevention practices are properly implemented. You can validate that they are working and having the intended impact. It can also help identify weak spots that require corrective action. And as if those reasons aren't enough, having a hearing loss prevention program in place when it is needed is required by law. So when is a hearing loss prevention program needed? OSHA, the Occupational Safety and Health Administration, supplies the answer in the OSHA Noise Standard, 29 CFR 1910.95 in the U.S. Code of Federal Regulations. Depending on where you live or the industry in which you work, you may have other or additional regulations to comply with, or your workplace may have specific policies in place that are more stringent, as is the case with my employer. OSHA requires that you implement a hearing loss prevention program when an employee's noise exposure reaches the action level. This occurs when an employee is exposed to an 8-hour time-weighted average noise exposure level greater than or equal to 85 dBA. In other words, when a worker is exposed to an accumulated 85 dBA noise level averaged over an entire 8-hour shift. It takes into account the noisy periods as well as the quiet periods. 85 dBA is also considered a 50% noise dose for the workday, as defined by OSHA. When the 8-hour time-weighted average exposure level reaches 90 dBA, this is considered a 100% dose. It is also called the permissible exposure limit, or PEL, and is the maximum amount of accumulated noise that workers can be exposed to when averaged over the workday. The OSHA Noise Standard also spells out the elements to be included in a hearing loss prevention program. We'll go over each of these a little deeper, beginning with noise measurements. There are 3 domains of sound that need to be considered when measuring or monitoring noise: frequency, amplitude or intensity, and time. Fortunately, modern properly calibrated sound level meters make it relatively easy to sort all this out. The frequency domain is accommodated by the A or C weighting scales, and C weighting is used if you are primarily interested in how much noise a machine is producing, like when comparing one machine to determine which one is louder. Use A weighting for measurements related to hearing damage risk, such as your worker's noise exposure. If you have further questions about these weighting filters, we may have time at the end of the presentation to discuss these, or you can email your inquiries to me. My email address will be given at the end of the presentation. The amplitude or intensity domain reflects the sound level, or what we perceive as the loudness of a sound. Its unit of measure is the decibel, or dB. Your sound level meter probably has several decibel ranges. You'll want to choose the one that encompasses the levels you expect to measure. For our purposes, the time domain has two definitions. It refers to the duration of noise exposure, that is the length of time that workers are exposed to a particular intensity of sound, and it also refers to the sampling time or time scale of the measurement, usually denoted on the sound level meter as fast or slow. For measurements of noise exposure, use the A-weighting filter and the slow time scale, along with a decibel range that is wide enough to include the action level, 85 dBA, and the highest intensity we expect to measure, say 105 dBA. These settings will accommodate most measurements typical of most workplaces that experience relatively continuous noise levels. If you have impact noises in your work environment, that changes things a bit. We won't go into the details here, but as with questions about frequency weighting, please feel free to inquire later. Noise monitoring can be accomplished by either area monitoring with your sound level meter or by personal noise exposure monitoring, often referred to as dosimetry. Area monitoring with a sound level meter is useful if your noise levels are fairly constant and your workers are relatively stationary. If workers are mobile or noise levels vary, then personal noise exposure monitoring is more useful. Personal noise exposure monitoring uses a sort of wearable sound level meter that averages the noise exposure from one representative employee throughout the workday. Personal noise exposure monitoring can be reported in terms of the time-weighted average noise exposure level, or the dose, which is expressed as a percentage of the PEL. OSHA also says you must repeat these measurements whenever a change in production, process, equipment, or noise controls potentially increases the noise exposures. For the next component, hearing tests need to be performed annually on every worker in the hearing loss prevention program and carried out in an appropriate test environment using calibrated equipment. Audiometry is about measuring hearing sensitivity or threshold, that is, determining the softest sound that a worker can hear. This can only be accomplished in a test environment with a very low ambient noise level, so an appropriate test location is one that is very quiet. Another important part of this hearing evaluation is to document any relevant medical history, noise exposure information, and use of hearing protection. Workers should be asked what type of hearing protection they are using, and when, where, and how they are using it. A baseline hearing test is to be completed before a new employee starts working and the results recorded on an audiogram. An audiogram is the graph you see on the right that displays the hearing thresholds by frequency in both ears, right for red and left is blue. Baseline audiograms need to be obtained before any noise exposure has occurred. Future annual hearing test results are compared to the baseline to identify any changes that may have occurred. The change to look for is the standard threshold shift, or STS, which involves a little math to calculate. If a threshold shift is found, the employee must have his or her hearing retested within 30 days. If the shift is confirmed by the second test, then the baseline audiogram is revised to reflect the changes, and next year's annual audiogram will be compared against the revised baseline to see if any additional changes have occurred. Throughout this process, the employee is to be kept apprised of all results. It is assumed at this point that all feasible engineering and administrative controls to reduce noise exposure have been put into place. If so, component number 3 is hearing protection. Employers are required to provide a variety of different hearing protectors with suitable attenuation characteristics. What is suitable is going to depend on a variety of factors particular to the workplace and individual workers. We'll address those factors later, but suffice it to say that whatever hearing protectors are used, they must be properly fit and correct use must be demonstrated. That workers know how to use their hearing protection properly is a requirement of a hearing loss prevention program. OSHA requires employers to make hearing protectors available when the 8-hour time-weighted average noise exposure reaches the action level, or 85 dB. However, when the exposure level exceeds the PEL, or 90 dBA, worker use of hearing protection is mandatory and must be enforced by management. Mandatory use of hearing protection is also required if a worker has already experienced the standard threshold shift. When worker exposure levels at the workplace reach 105 dBA, then workers need to double protection, which means wearing an earmuff over well-fit earplugs. Training of employees in the hearing loss prevention program also needs to be completed prior to beginning work and repeated annually. Training should include the effects of noise on hearing, the purpose of hearing protectors, some advantages, disadvantages, and attenuation of various types of hearing protectors, and information on their selection, fitting, use, and care. Proper fitting of hearing protectors should be demonstrated so workers can feel confident in their use and safety managers can feel confident that workers are properly protected. Training should also include an explanation of the hearing test, including the results and its purpose. The purpose and scope of the hearing loss prevention program should also be included in the discussion so workers understand how the hearing loss prevention program functions and what their responsibilities are within the program. Each of the elements discussed so far generates some kind of data to be collected and maintained as part of a hearing loss prevention program, including some we haven't touched on yet. These data will all need to be stored and managed. Occasionally, legal cases arise involving occupational hearing loss, which is all the more reason to keep careful records. Employers should be able to demonstrate that they meet or exceed OSHA's requirements in the event of a safety audit. Any workers with a standard threshold shift need to have it recorded in the OSHA 300 log. That's a record you probably don't want, but you need to keep it nonetheless. Beyond the basic business and regulatory requirements to store and maintain these records, the data they contain may be useful in managing the entire hearing loss prevention program if they can be navigated, sorted, organized, and analyzed. After delineating the components comprising a hearing loss prevention program, the challenges presented in implementing them may seem a bit overwhelming. So let's go back through each of the component parts of the program and see how and where technology can assist in implementation and benefit the hearing loss prevention program overall. The biggest challenge with noise measurement is obtaining accurate exposure data over time. Even relatively constant noise varies from time to time and from location to location. An individual worker may operate different machines with different noise levels over the course of a shift, or may move around the work site to carry out different tasks. Ideally, each individual should have something akin to a personal hearing loss prevention program for themselves. How can all this variability be accurately measured? How can we make hearing loss prevention more personal? As mentioned earlier, there are two ways to measure noise exposure, either through area measurements or personal noise exposure monitoring. The technology used for area measurements is typically a sound level meter. These come with various features and various levels of technology, but most will perform the basic task of measuring workplace noise levels. Higher technology devices include features such as frequency analysis and graphical displays, and the ability to store and transfer data to a computer. New on the scene are sound level meter apps for smartphones. These apps can turn your cell phone into a basic sound level meter. Although they have been shown to be fairly accurate, they do require calibration, which can be tricky without the right equipment. Even the best smartphone apps are not yet recognized by OSHA as meeting the standards for a proper sound level meter. So you can't use your phone for official noise exposure risk assessments in a hearing loss prevention program. You can, however, use these to monitor changes in workplace noise levels or identify hotspots for noise that may benefit from engineering controls. For example, if there's a process change or a new process tool, you can see if that change resulted in a noise level difference large enough to trigger an official reassessment of noise levels. Or you can compare the noise levels emitted by two different pieces of equipment as part of a purchase decision. Personal noise exposure monitoring is intended to measure the noise exposure of the person wearing the device. Worn on the shoulder, the device is close to the ear, so it averages the noise levels at the worker's ear whenever he or she goes, or wherever he or she goes throughout the day. But there is a problem. The device does not account for any hearing protection the worker may be wearing. It's only measuring the noise exposure level as if the worker were unprotected. If the worker is wearing hearing protection, the device doesn't know if the hearing protection is being worn correctly or how well the worker is protected. New technology is now available that can take personal noise exposure measurements of not only the worker's environment, but under the hearing protector as well. This dose at the ear measurement is the noise exposure level that is actually reaching the worker's protected ear. As these new hearing protectors monitor noise exposure, they can alert the wearer when their dose is approaching its limit, or estimate how much time the worker can remain in a particular noise environment, and provide continuous fit testing data for the hearing protector throughout the day. These devices can also store the noise exposure data they have collected and upload it to a computer or a mobile device for analysis. One challenge with audiometric testing is finding the most efficient way to conduct the hearing tests, minimizing the amount of time each worker spends away from the job. The least efficient is probably to send workers to an external test site. This adds travel as well as time to the testing process. When workers do go off-site, they are most likely tested in a sound-treated booth like the one you see here in the upper left. This is an appropriate test environment as required by OSHA, so at least you know your test results are accurate. A mobile testing van can come right to your door. This is a convenient option, especially for large employers with a significant portion of their workforce enrolled in a hearing loss prevention program. A mobile unit will likely have several smaller versions of that quiet testing booth right inside the truck, also satisfying OSHA's requirement for an appropriate test space. Several workers can be tested simultaneously at the work site, so it is a big step up in efficiency. Newer technologies are portable audiometers or audiometer apps that facilitate hearing tests virtually anywhere, as long as it's quiet enough. These apps usually run on an iPad and use specialized headphones, like those shown on the bottom right, that have noise-isolating ear cups. In a quiet office, these can be used to bring the noise level under the ear cups down to the levels required by OSHA, almost as if strapping that sound booth right on the sides of the worker's head. The headphones can also measure the ambient room noise to determine if the space is quiet enough for testing. Selecting the right hearing protector should be a non-issue, right? You either shove something into the ear canal or slap something over the ears. Sorry, but it's not that simple. I'm here to tell you that what's pictured here are not hearing protectors. Unfortunately, there is no one single hearing protection solution that is appropriate for every person, every noise environment, or every work site or task. So how does one choose from among the myriad hearing protectors on the market? Selection of an appropriate hearing protector involves several considerations, but comfort is the primary factor to consider when selecting hearing protection. A hearing protector that isn't comfortable won't be worn, and therefore won't provide any protection, no matter how big the noise attenuation number printed on the box. Every worker is unique and will have different ear sizes and shapes, even on the same person. Finding the right fit is crucial to getting the right amount of attenuation. Workers may also have different levels of noise exposure, so some workers will need more attenuation than others. Different job requirements may also drive hearing protector selection. For example, if a job requires donning and doffing the hearing protector in a dirty environment, workers may want to avoid roll-down foam earplugs and choose an earmuff or a banded earplug instead. Confined spaces may require something with a low profile, and those working with high-voltage electrical systems will need hearing protectors constructed from dielectric materials. Consider the importance of communication and other safety risks. How important is it that a worker can hear his coworkers? Are there backup alarms and other warning signals that a worker needs to hear? This will factor into the decision as to which hearing protector is most appropriate. Does the worker wear other personal protective equipment, like the like the worker pictured on the right, hearing protection should be compatible with other PPE. So, how do you have confidence in the hearing protection you choose? How do you know it is being used properly? Are your workers confident in their use of their hearing protection? And are they confident that their hearing protection is adequately protecting them? We tend to rely on published attenuating ratings like the noise reduction rating, or NRR, that we use in the United States. The NRR is a laboratory estimate of the attenuation 98% of workers may achieve, assuming the hearing protector is fit properly. It is based on the test results of 10 laboratory subjects who are most likely experienced at fitting hearing protectors and executing the test, and who are most likely not factory workers. It really tells you nothing about the attenuation an individual worker is actually getting. In fact, there's a rumor going around that NRR actually stands for not really relevant. For the earplugs shown, the NRR printed on the box is 33 dB. Worker 1 and Worker 2 are both wearing the same earplug. They both seem to have their earplugs well into their ear canals. Maybe worker number 2 has it in deeper, but both workers appear to be protected from noise. When we measure the actual attenuation, however, we find that worker number 1 is getting no protection. If you look closely, there are tiny gaps between the earplug and the ear that are letting in noise. Worker number 2 is actually getting 34 dB of attenuation, more than the published attenuation rating. The challenge here is that you can't tell from the number on the box if an earplug is going to work for an individual worker, and you can't tell by looking at the earplug in the ear. You can't really have confidence in the fit of an earplug and the amount of attenuation it provides a particular worker unless you measure it. This is where individual fit testing comes in. Fit testing is a fairly complex measurement, so it requires a technology solution in order to simplify it. There are several different fit testing systems available, and they all work a little differently, so you have to determine what's right for your workplace. Some systems test hearing using thresholds, so a quiet test space is essential, while others test above hearing thresholds and can tolerate a higher background noise level. Some systems can test any earplug from any manufacturer, including custom earplugs, and some systems are restricted to testing exclusively the earplugs of a single manufacturer. Some systems can even test earmuffs, but testing earplugs is where the greatest value of fit testing lies, since earplugs tend to give wearers the most trouble with fitting. Honeywell makes the VeriPro system pictured in this slide. Nearly all fit testing systems will measure and calculate a personal attenuation rating, or PAR. Rather than relying on a guesstimate like the NRR, the PAR, or PAR, will tell you the actual attenuation that an individual worker can achieve with a given earplug. Fit testing also allows a worker to try different styles and sizes of earplugs to see which one gives the right attenuation. They can also see which type is easier to use and which type is more comfortable for them to wear. Importantly, individual fit testing is the ideal opportunity to train workers in the proper selection and use of their hearing protection as required by the OSHA noise standard. Research from the National Institutes of Occupational Safety and Health, or NIOSH, show unequivocally that one-on-one, face-to-face training results in significantly better earplug fitting success than either the manufacturer's written instructions or individual or group video training. Plus, fit testing systems log the training activity along with the test results, providing the hearing protector training record necessary for an effective hearing loss prevention program. It is difficult enough to hear and communicate in the presence of background noise, but adding hearing protection significantly increases that challenge. It may also put workers at risk may put workers at additional risk, depending on the demands of their job. The inability to hear auditory alarms or other warnings is highest on this list. Job performance may also suffer if workers can't hear verbal instructions or if they need to monitor machinery sounds to ensure proper operation. And feeling isolated at work can lead to poor job satisfaction and mental well-being, and can even decrease productivity. The challenge is to bring noise exposure at the ear down to safe levels while minimizing the impact on important sounds that workers still need to hear. One technology solution to this problem is electronic hearing protection. You may hear this referred to by many different names, but most electronic hearing protection will include amplification of softer sounds like speech, among several other features. Nevertheless, any headset that delivers any type of auditory signal to the ear from loudspeakers inside the ear cups needs to limit those signals to safe levels. Otherwise, they do not qualify as hearing protectors. Electronic hearing protection has two main components. The first is the traditional physical barrier, the ear cup with its foam and cushion that attenuates the environmental noise reaching the ear. This barrier not only reduces the level of loud occupational noise, but also softer environmental sounds like speech. It isn't smart enough by itself to know the difference between the two. So the second component, the electronic circuitry comprising a microphone on the outside of the ear cup, amplifies the sound and limits the sound coming out of the loudspeaker. It limits them so that they are not so loud that they are unsafe. A well-designed device will limit amplified signals to no more than 82 dBA. We call this output limiting compression because the circuit compresses a large range of sound, called the dynamic range, into a smaller range and limits the top of the range to 82 dBA as shown on the right. A whisper, for example, at around 30 dBA would be inaudible with the hearing protector in place, but the amplifier will make it easier to hear. A comfortable sound, like conversational speech, may be amplified only slightly, but a loud sound, like a lawnmower, or a very loud sound, like a leaf blower, will be limited to only 82 dBA from the loudspeaker. A common misunderstanding, especially among shooting sports enthusiasts, is that electronic earmuffs will muffle the sound of an intense impact or impulse like a firearm to 82 dBA. This is not the case. Keep in mind that the physical barrier provides the hearing protection, not the compression limiting circuit. An earmuff with 22 dB of attenuation against a 140 dB peak rifle shot will still result in 118 dB peak impulse under the ear cup. It's just that whatever is produced by the loudspeaker is not contributing to the unsafe noise level. A lot of available hearing protection may include other features to benefit hearing loss prevention programs and individual workers. The hear-through amplification that assists with communication can also help maintain situational awareness as long as the external microphones are binaural, that is, a separate microphone and amplifier for each ear cup. Workers with hearing loss may find these hearing protectors useful with and without hearing aids, depending on the severity of their hearing loss, because of the amplification of softer sounds. Some of these electronic hearing protectors can connect to other devices via wired and wireless connections, so you can take phone calls or stream music if that's allowed in your workplace. Some will even accommodate custom connections to two-way radios, moving the microphones to inside the ear canal and push-to-talk access to a more convenient location. Technology in newer devices can perform real-time fit testing and, as mentioned earlier, dose-at-the-ear personal noise exposure monitoring. The hearing protector itself can tell the wearer how much attenuation it's providing. Rather than do a fit test once a year and hope the worker remembers how to achieve that ideal fit, fit testing takes place on a real-time, continuous basis. Many of the systems that measure personal noise exposure throughout the day provide alerts to the user when they are approaching their maximum permissible exposure limit, or inform them of how much longer they can safely remain in a noisy environment. Many of these systems can then upload their accumulated noise exposure data to a mobile app or a central system for storage and later analysis. As we discussed, fit testing is a golden opportunity to train employees on the selection and use of hearing protection. You can know if the training was effective if employees continue to achieve adequate PARs on subsequent fit testing sessions, and you have a record of that training. The same can be said of the training associated with annual audiometric testing. But what about training in other areas that OSHA requires, like the purpose of the hearing loss prevention program and employees' roles and responsibilities within it? How do you make sure the message was received and understood? A traditional delivery method for these trainings is a toolbox or tailgate talk. These are useful when getting workers together at a time when they are used to receiving information, but it might be impractical to assess their grasp of the message at that time. Video technology can reach larger groups of workers at once, but again, assessment can be problematic. Online learning management systems, however, can make video training interactive, and assessment can be interactive and personalized as well, with a quiz and a certificate. Technology used in this way ensures not only that the message was received, but that it was understood. Quiz results are evidence that OSHA-required annual training was completed and demonstrates the level of competence received or achieved by the employees enrolled in the hearing loss prevention program. The challenge with record keeping is storing and managing all the data that's generated by and accumulated for a hearing loss prevention program, and then making it easy to navigate, access, and put to meaningful use. Cat videos may be fun, but data management and analysis is what technology was really created for. Smart technology devices will not only generate data, they will provide a way to extract or upload that data to a central storage and management system. But even this isn't enough. Once the data have been uploaded, parsed, and stored, what do you do with it? Perhaps a better question is, what can you do with it? Or maybe the best question is, what do you want to do with it? Cloud-based storage, with which you are probably already familiar and perhaps already using with other software applications, is a fantastic tool for data storage for several reasons. It allows data to reside remotely in a central location rather than on a single physical hard drive dedicated to one computer. This is essential if multiple work locations are uploading data for a common use or purpose, or if several managers need access to the data. Storing, sharing, and retrieving data are much more efficient. For example, OSHA requires that if an employee requests a copy of their hearing test, it must be provided. It's much easier to locate and retrieve it from a virtual central location that doesn't rely on dedicated hardware, like a computer that could be locked away in someone's office or taken out of service as part of a leasing agreement. And many of the technology solutions that we've discussed can all work together. Some of the products we've talked about can send data straight to the cloud. For instance, fit testing systems can send PAR and training data to the cloud. Personal noise exposure monitoring headsets can log data to a local device like a smartphone app that can send noise exposure measurements and dose data to the cloud. Having all the data in one place, software programs can be used to analyze the data to look for trends, highlight trouble spots, manage hearing protector inventory, or identify at-risk workers or more. This leads to our next challenge, using the data to identify workers who are at risk for hearing loss. The cache of data residing in the cloud consists of lagging and leading indicators. Within each category are some indicators that are more reliable than others. The less reliable lagging indicators at the upper left are nearly useless. Hearing damage is happening and we don't have a baseline. That is, did the employee have tinnitus yesterday or last year, or did it just start today? Looking at the group at the bottom left, while an audiogram can inform us of the seriousness of a hearing loss, we certainly don't want to wait for our audiometric testing to confirm the presence of a standard threshold shift, because this indicates that a permanent hearing loss has already occurred. The leading indicators on the right side warn us in advance of potential problems and help us avoid them. Use of leading indicators is proactive. Relying on lagging indicators is a reactive approach. Ideally, the most reliable leading indicators, those at the bottom right, should be employed, and technology can help us assemble a dashboard that provides an adequate visual overview of the entire hearing loss prevention program. Being able to visualize as color-coded or graphical elements these data is much more efficient and much more intuitive than combing through numbers. These data can be sorted, arranged, and graphed in myriad combinations to assess the overall effectiveness of the hearing loss prevention program and flag potential issues by location, work group or department, or some other category. Safety managers can drill down to investigate root causes, monitor and track individual worker behaviors over time, see what hearing protectors are and are not being used so inventory and buying decisions can be adjusted, and probably several other problem-solving and reporting solutions unique to your hearing loss prevention milieu that I haven't even thought to mention. Here's a real-world example of how this technology benefited a user. One of our customers using the smart hearing solution changed their requirements for hearing protection required zones throughout their plant after the system alerted them to a solution that was otherwise difficult to observe. Workers going on breaks were removing their hearing protection before walking through areas of hazardous noise. The smart headset not only provided the data necessary to discover the issue, but those data also showed that this practice was putting the workers over their permissible exposure limits for the day just by taking breaks and visiting the restroom. There are many software programs that can help you display data in a graph or chart. Even something as basic as Excel has features that can be exploited once data are organized in a central cloud storage system. The new proprietary commercial software programs specific to safety and hearing loss prevention will do most of the work for you. These systems integrate with many different types of smart and connected personal protective equipment and make use of machine learning algorithms to predict trends before safety managers may be able to tease them out of the data for themselves, as in the example that I just presented. As with most new technology, there may be an initial investment and learning curve, but applying the technology to proactively prevent hearing loss rather than documenting it after the fact will reduce effort, expense, and time, not to mention occupational hearing losses, in the long run. I hope I presented some new information today and that you've been able to glean at least something thought-provoking, if not immediately applicable to your hearing loss prevention program. I appreciate the time you've allocated to me from your busy schedules, and I wish you all the best in your hearing loss prevention efforts. Now I think we have some time for Q&A.
All right, thank you, Bob,
Alan?
for your expertise. Thank you, Bob, for your expertise and insightful presentation. Before we start the Q&A, I want to remind everyone of the evaluation survey we're asking you to complete. That survey should be appearing on your screen now. Your input is important because it'll help us improve our future webcast. If you do not see the evaluation survey on your screen, please turn off your pop-up blocker. You may also access the survey by clicking the survey button near the lower right part of your screen. Okay, now we're going to get to some questions. If the first one, if someone only works in noise once a week, do they need to be in the hearing conservation program?
So in this case, you need to measure the noise that they're exposed to. So if the time that they're in the noise puts them over that PEL, then they're in trouble. If the noise that they're exposed to during the short amount of time that they're in that noise does not reach 85 dBA, then they do not need to be included in the hearing loss prevention program. But you have to measure it. That gets back to that basic idea that you don't know unless you measure.
Okay, so our next question, with the new hearing technologies you mentioned, how is a user alerted if they are nearing their daily exposure limit?
So they'll get a voice alert telling them how close they're getting, what their exposure level is, and that they're getting close to that limit. There's also an external signal light on the side so that the safety managers or production supervisors or whoever is monitoring these workers in their work at the work site can see externally if the worker is safe or if they're getting close to exceeding their permissible exposure limit.
So our next question, what is the benefit of revising the baseline? Why wouldn't the original baseline be used for the employee on every test?
The original baseline will always be available, but the only way to see if there is a standard threshold shift, the way OSHA calculates it, is to go back to the previous year's test. So if they had no change in their hearing, the baseline will stay the same. If there is a change in their hearing, that baseline needs to be revised so that if there's a change in the audiogram for the next year, they have a new baseline from which to calculate that change. It all has to do with how OSHA calculates that standard threshold shift.
So our next question, can I administer fit testing and hearing tests myself, or do I absolutely have to outsource to another company? And this person asked, do I need specific training?
Yes, so as far as the audiometric exams go, there is a requirement that in the OSHA noise standard that those tests be administered by a person who has the proper training to do those tests. And that proper training is recognized as having a degree and license as an audiologist or being certified by the occupational hearing conservation program administrators as being a certified occupational hearing conservationist. This is through the KOC program. As far as fit testing goes, that can be done by anybody who's had a little bit of training on whatever system they're using to do the fit testing. And that training can usually be provided by the manufacturer of the fit testing system.
So our next question, why is it that sometimes an employee can show a recordable shift and then that shift persists 4 years, but 4 years later after it's documented, then they sometimes can show an improvement? Should that be possible?
Yes, it's possible. It's not very probable, but it is possible. When we do the hearing test, as OSHA requires, it's an air conduction test only. If we see a standard threshold shift, we need to follow up in 30 days. And if that hearing loss persists in 30 days, then we say that it's a permanent standard threshold shift. The reason we give them 30 days is because we can get an air conduction shift in thresholds due to a cold or something like that, some kind of congestion. And we expect those generally to resolve themselves within that amount of time. But there are conditions that are not related to noise exposure that may persist beyond the 30 days and may correct themselves later on, or may be corrected by some medical intervention. So that threshold shift will go back, will be reversed, if you will. And I know the next question is probably going to be, so what do we do about it at that point? And I haven't seen any guidance from OSHA on that yet. That doesn't mean that it doesn't exist. It just means that I'm not familiar with it. And so I'll have to go and research that and see if there's any guidance from OSHA.
Got a two-part question here. So are you saying the hearing protection will screen out loud noises and you can still pick up the voice of a coworker? But what if the worker is in a constant 110 decibel environment and the coworker is talking to them from a short distance away? Will they still be able to hear their coworker?
Depending on how loud that noise is at the location where the conversation is taking place, there will be still some difficulty. The idea behind this is that when you're wearing the hearing protection, you don't want to take it off in noise, but people will still want to talk to you. And most noise environments, probably 85% of the noise environments, aren't going to exceed 90 to 95 dBA. So the really difficult ones that get up over 100 dBA, those are still going to be a challenge to communicate, even with a communication earmuff. And actually, when you get into those kinds of levels, even OSHA recommends, and a lot of manufacturers will recommend, that you use dual protection and just forego the communication in that noisy environment. There will have to be some administrative controls put into place to facilitate communication when the noise levels are that loud.
Our next question, do you think it's necessary to get a meter that has a calibrator? What do you think is the downside of purchasing a sound level meter without a calibrator?
Well, you need to calibrate your sound level meter. You can either send it off to a laboratory to have that work done, or what I do is I have a calibrator for mine, and I send both the meter and the calibrator to a metrology lab to have both of them calibrated, so that when I check my calibration throughout the year, I know that it's going to be accurate. Then I have the sound level meter itself and the calibrator checked annually at this metrology lab. I don't recommend that you use an OSHA specified sound level meter like a type 1 or type 2 sound level meter without a calibrator for any official measurements. If you do and you get audited and you cannot show that the sound level meter was properly calibrated, there may be a question about that.
Our next question, how often can you retest an employee within a year or within 12 months?
As far as audiometric testing, as often as you want, as often as you like. In fact, in some cases, for instance, if there are certain ototoxic chemicals, these are chemicals that are poisonous to the ear, like styrenes and benzene and certain hexanes, things that you might find with painting or adhesives or fuel processing or something like that. If workers are exposed to those chemicals in addition to the noise, they're going to be put at much greater risk for hearing loss than if they're exposed to the noise alone. And in those cases, you may want to check those employees' hearing much more frequently than annually.
I'm sorry, did you get that question?
I just got bumped off temporarily. I don't know what happened there. What was the question?
Welcome back. I said,
Thanks.
can you speak to the fit achieved with smart muffs when used along with safety glasses? Often it's not easy to achieve a good fit because of the temple bars. Is that correct?
That is correct. It can be done, but you've got to make a choice. I mean, a lot of workers like to use the more modern sports-styled safety glasses, and they have thicker frames, and they may even bow out from the side of the head, and those are going to disturb the seal of any earmuff. So there are safety glasses out there that have thinner frames that fit close to the side of the head and that are relatively compliant. So the pressure of the earmuff on the side of the head will push them down against the side of the head, and they will result in little or no leakage. But it has to be tested, and again, you don't know unless you test it. But the safe route to go here is to find safety eyewear to wear with earmuffs that can accommodate that. Thin frames that fit close to the side of the head.
So our next question: can a worker use a cell phone app or other device to show the PEL?
To show how close they are to the PEL? Yeah, or in the case of, let's go back to this slide. I guess you can see it here. This shows a percent dose on a worker's cell phone. It shows that percentage, 64% of their dose, where 100% dose is the PEL. So they can see how much time they have left that they can work in that environment. They can see how far away from 100% dose they are, given the time of day that they're currently at.
Our next question, this person asked, during a recent annual on-site audiograms, employees were offered reusable earplugs. How can we ensure our employees clean these reusable earplugs? How frequently should they be replaced? And if the company provides these as a PPE option, is there a liability on the company if the employee does not clean them properly?
I don't have a good way to ensure that they're cleaning them, but I would make sure that the employee knows that if they don't clean them, that the accumulation of detritus and biological junk on there can potentially lead to an ear infection. That said, if they are cleaned properly, just wipe down with a gentle detergent, hand soap even, and then dried, they can last many weeks, 3 or 4 weeks. They can be used. Now, some people have different body chemistries, and it will harden the plastics. They might have to be replaced more frequently than 3 weeks. But typically I see 3 or 4 weeks easily from those, as long as they're cared for properly.
I think we have time for one more question. We have two questions about this. The requirement for double hearing protection at more than 105 dBA, where does that come from? A couple of people don't recall seeing this in any regulations. Is that from OSHA? Is that from another regulatory body?
There are conventions, like from NIOSH, which is not a regulatory agency. They are an informative group. They will recommend dual protection at different levels, and a lot depends on the type of noise. If it's if it's a continuous situation like sandblasting, if you're trying to clear crusted material off of the hull of a ship or some kind of a metal duct, the worker is in a confined space with a very, very loud noise, sometimes up to 110 dB, and the requirements there might be set by the employer. But I've also seen recommendations that dual protection be used starting at 100 dBA. So 105 is kind of by convention. I do not think that OSHA has a specific requirement for dual protection there. The only thing that they do limit is 115 dBA for any length of time for any employee. That's a do not exceed limit.
All right, thank you, everyone. Unfortunately, we have run out of time. I'm sorry we didn't get to everyone's questions, but as a reminder, all of today's unanswered questions will be forwarded to our speaker. Once again, I hope you take the time to fill out the evaluation survey to give us your feedback. That ends today's Safety and Health Magazine webcast. I'd like to thank Bob Gent, everyone at Honeywell and the Howard Light Acoustical Testing Laboratory, and of course all of our listeners. Please have a safe day.